All right, hello everybody. My name is Derek Demeter, and welcome to episode 8 of our virtual star party. Joining me, as always, we have our telescope operator engineer, Frank Kane. Frank, that is a amazing shirt that you got on tonight.
It is. I'm proud to wear it, and later on I can talk about how you too can get your very own CFAS shirt.
Sweet. And of course, we have our Commander-in-Chief, Communications Officer, and cat friend extraordinaire, Jason.
Welcome. Yeah. This is Nova, my supernova. Thought I'd give her an introduction tonight. I'll let her go back there. But yes, happy to be here.
And you too are wearing a very amazing shirt tonight.
It really is a fantastic shirt.
Yeah. And so we've been promoting this organization. We'll talk about more about that later on. And I'm also wearing a shirts with stars, because that's all we're talking about tonight. We're talking about explosive stars, right? Supernovas, all kinds of supernovas. That's what we're going to talk about tonight during our star party. And so let's start off with this supernova thing. What is a supernova? Do you guys want to share a little bit about what a supernova is, or maybe even just a brief little definition of what does it mean to be a supernova? Go for it.
Go, Frank. You take it.
Well, the short answer is a star that blows up and makes a whole lot of light in the process. And, these are cataclysmic events that can be seen from tens of millions of light years away, even farther. They are massive, massive energetic events. And there's a few different ways they can form, right? And we're going to see a couple of them tonight.
That's right. Not only are we going to be looking at things in the sky tonight, I have a really cool software that you can purchase yourself at home or download at home called Space Engine. This software is absolutely amazing. We've been using it for some of our field trip programs at the Planetarium, and we're going to show you all some really cool things that we can share in that software later on when we do that. But now,
have you guys heard of an astronomer called Carl Sagan?
Yes.
Rings a bell, yeah.
He's pretty sound familiar, right?
Yeah.
One of my favorite quotes from him was regarding supernova is that we are all made of what?
Star stuff.
Star stuff.
I was going to say Cheez-Its, but that's okay. No.
Okay.
Same thing.
Well,
Same.
fiery hot Cheetos is also an acceptable answer.
Exactly.
But yeah, we're all made of star stuff. So, I mean, one of the cool things is, just if you've got, I don't know, a ring on your finger, a gold ring, or maybe you're wearing earrings or a necklace. I mean, just touch that. That element, gold or titanium, whatever you've got there, came from a high mass star that exploded. Just to think of that, not only just that the elements inside of us came from exploding stars, but we are here because of the death of many stars. So pretty cool.
And plenty of that. And what's really interesting is that cultures around the world have seen supernovas actually go off. For example, the Chinese are some of the best recorders of supernova events in human history. Thousands of years of recordings. They saw them as what we call guest stars. They were these miraculous things. And usually when a supernova or a comet would appear, this was a time of either great unrest or it might herald something new, something exciting. And a lot of cultures saw that. And Justin, you mentioned earlier about this thing called Chaco Canyon. It's actually a site I've been to in New Mexico. It's a really cool site, but you wanted to bring that up a little bit. There's actually some really interesting evidence of a potential supernova that has gone off there.
Yeah, I mean, one of the dates that are going down in recorded history is July 4th of 1054. And in this part of New Mexico, in this canyon, you've had this ancient civilization that documented what we believe now is the Crab Nebula, right? Now you were there. You were able to get. What would this be considered a pictograph?
Yeah. So a pictograph is actually something that's drawn. A petroglyph is using smoke and then kind of tracing it. So this was a pictograph. Somebody was actually painting this onto the stone. What's interesting is in this picture here. First off, you got to hike about 6 miles out to this site. So it's not like you're just showing up, parking your car right next to it and looking at it. You got to walk. I remember my buddy and I, we had to cross a river. We actually had to swim in this river to get to the other side. to get to this spot. So this was an incredible adventure just to get here. But this is actually on a ceiling, or on the ceiling of a rock wall. So I'm actually pointing my camera up towards that site. And so you have to ask yourselves, what was going on here? There must have been another ledge. There must have been something right here for them to climb up. It must have collapsed a long time ago. But back then, you know, this could have been a ledge. They would have climbed up. They would have been able to get to the top of this and actually put it up.
Just amazing that, you know, we got this type of event documented. And my calendar must have known we were going to do this show tonight, because, again, I think we talked about this last week. But, you know, this is the event that kind of created that image that Mr. Derek, you took of this, you know, ancient artwork in the New Mexico desert. And we're talking about an object that is, what is Crab Nebula, 6,500 light years away?
Yeah, pretty far away. It's located in one of the horns near the star Alnath in the constellation of Taurus. And imagine now today, we can't even see this object with the naked eye. We have to use a telescope to look at it. But imagine this star becoming brighter than any other star in your sky at night. And you could actually, there have been records that some supernovas are bright enough to be seen, and you can actually read under them at night. Could you imagine reading a book or looking at something, or maybe even a shadow casted of you from a supernova from such a far distance?
Yeah, it's crazy. I remember when they were talking about the possibility of Betelgeuse exploding, they said it would be as bright as the full moon at night, and that's just really hard to wrap your head around.
It's just incredible. And speaking of Betelgeuse, what I find really interesting is that Betelgeuse, should I say it again?
Do it.
Betelgeuse. Oh, okay. Okay. So we're all right. We're all right, guys. We're all right. So basically, Betelgeuse has kind of gotten this, you know, major publicity lately with being this getting dimmer, and we're thinking, oh man, this thing's going to explode as a supernova. But in reality, Betelgeuse is not exactly what we're expecting to be the next upcoming explosion. So basically, Betelgeuse is a supermassive star, 900 times the size of our sun. It's going to the core of this star is going to collapse. And when it collapses so much that all the electrons are basically forced together in a very small space. And when this happens, a sheer amount of energy is radiating out, shockwave blows up the star into this massive explosion that becomes so bright you could see it for, you know, all in distant galaxies, which we're going to be looking at in just a few minutes here. But that's what's going to happen to Betelgeuse at some point in time. And with Space Engine, we're actually going to take you all on a trip to Betelgeuse. So what I'm going to do here is I'm going to go ahead and start sharing my screen. All right, we're going to share my screen here. So let me know. Are you guys seeing that?
Yeah, we're good.
All right, so
Beautiful.
right now we're actually at another supernova, but we're going to go visit Betelgeuse. And Betelgeuse is a star that is becoming incredibly unstable. It's becoming extremely unstable. Look at this star. This star doesn't even look like an actual, it doesn't even look like
a baked
star.
potato.
Yeah, that it just doesn't have the same look as, let me go ahead and reduce the exposure a little bit so we can see the star a little bit. But this star is actually showing signs of breaking apart. And one of the things we've discovered with Betelgeuse, and the reason why it got so dim, is that you can see here, if I increase the exposure, you can see that Betelgeuse has a lot of this dust surrounding it. And that's actually not dust, it's gas, hot plasma that's shedding off of the outer layers of that star. And what we can actually do here is we can speed up time a little bit, and we can actually see the pulsation of the star. And what happens is as the star sheds off its outer layers, some of that gas obscures the light a little bit of that star, and it dims the star down. This is something that we actually recently found evidence of. But eventually, at some point in the future, this star will go pop. This supernova will go pop. And when this happens, Betelgeuse, in our sky at night, again, Betelgeuse is a star in Orion, kind of in his armpit, will become about as bright as the full moon at night. Can you imagine the star all of a sudden becoming bright? And then all of a sudden, it will dim down, take a couple of months for that to do that. And then guess what? The star disappears altogether. So But
This is what really made it crazy for me. It was when I was looking up the distances here, when we looked at the Crab Nebula, which is 6,500 light years away, and it was so bright that you have ancient civilizations drawing about it. Betelgeuse is what, 640 light years away?
Yeah.
I
yes,
mean, that it
far.
is so much closer. So obviously, we're not in any danger, are we, Derek?
Not here. No, thank goodness we're past the blast zone, the blast radius. But if you were near a supernova, it would be a bad day for you. You would vaporize your atmosphere, basically cook you, sterilize you. It would just not be a good day for life. So what's interesting is that, Frank, I remember when you showed us your image of M61, you were imagining yourself. Imagine being in this place and this thing brightening up, and all of a sudden, imagine life there, right? It would just be kind of scary. And so we
Yeah.
actually got a chance to go out a couple of nights ago to image this this object, and we're going to show some of our photos that we've taken of this. But before we do that, Justin, you brought up something really cool earlier about the fact that we've been putting a lot of emphasis on Betelgeuse going off supernova, but you've discovered that there are other stars kind of in line to potentially go off before Betelgeuse, right?
Yeah, this might be a great time to bring up Stellarium and go over a couple of these stars
Sure, I'll go ahead and do
because,
that while you
yeah,
talk.
yeah, Betelgeuse gets all the fame right now because, well, I don't know why it does, but it is on the list of potential supernova stars. But while researching this a little bit further, it's actually sixth on the list. And one of the stars that we look at all the time, Spica, is second on the list. And Derek's going to kind of show you where Spica is in the night
Yeah,
sky.
so you're
This
going to
is,
look to the southeast, and you'll
yeah.
see up here is this beautiful brightish blue star. And up here, we got this star called Arcturus, really nice red star. And if you find that star, you can actually go down, and this beautiful blue star is called Spica. And Spica is actually in the constellation of Virgo. It's actually the main star in the constellation of Virgo here. So yeah, so Justin, tell us more about Spica, what you discovered.
Well, yeah, just the fact that it's only 250 light years away, so much
Whoa.
closer. Again, I think we're
Yeah.
probably safe if this one were to go supernova, obviously here on Earth. But the fact that Betelgeuse has been getting all the press, but this star that we see all the time, that is this beautiful star in our sky, is actually more likely based on the numbers to go supernova. And then you've got Antares, which I don't think is visible right now, right?
No, well, Antares, it will be visible in the morning. What we could do is we can speed up time. We can bring up our clock here, and we can go to the early morning. And if we look to the early morning over here, towards the south, we'll see a bright reddish star, Antares. And literally, Antares is basically anti-Mars or not Mars, just for those that. And in fact, actually, Mars is currently up in the sky tonight. It'll be rising here shortly. But yeah, there's Antares. So this also is also going to potentially explode, huh?
Yeah, I mean, in star years, this could explode any day, which could be probably in the next, million years. So we might miss it.
Well, hopefully for us, we might be fortunate to not have to deal with this. However, for those that are, going to be around for a while or are there in that time, that would be a bad time for us to have to deal with this. But thankfully, we have ways of maybe one day we'll be leaving Earth, or maybe one day we'll go somewhere further away from these sources of supernova events. So supernovas. There are different types of supernovas, and what's really interesting is there are two objects in the sky right now, two supernovas that have been currently observed that are the different types of supernovas. We have a type 1 supernova, and we have a type 2 supernova. And even type 1 has an A version, a B version, and a C version. But what we're going to do real quick is we're going to go ahead and take a look at one of those supernovas. And Frank, which one would we want to look at first? What do you recommend?
Oh, why don't we go straight to M61? That's a pretty one. So
All right.
I can pull up my
Now,
picture over there if you
remember,
want.
for those that are watching on Facebook, we love to hear from you. So make sure to comment, or if you have any questions throughout our program, Justin will be monitoring that the chat there. So if you have any questions or if you have anything that you want us to go over again, please do so. And if you're on YouTube, if you have any questions, leave those in the comments section below, and we'll do our best to reply to those questions at a later date. So, anyway, yeah, here we are. It's M61. So, Frank, can you tell us a little about what M61 is?
Yeah, this is one of the largest galaxies in the Virgo cluster, which is obviously located in the constellation Virgo. And it's about 50-ish million light years away. I think it's like 52 formally. So pretty far away as galaxies go. But we can still see this supernova here that's highlighted here by that red line there. Hopefully you can see that on the screen. And if you look at that, I mean, that looks just as bright as the entire core of that galaxy combined. And it looks just as bright as the stars that are in our own galaxy that are way closer than that to us, right? So it's really hard to wrap your head around just how bright this explosion is. And this was just discovered on May 6th. So, you know, it actually blew up. Well, I won't say recently because it was actually 50 million years ago, but from our perspective recently. And it's just getting brighter and brighter every day.
You know, you mentioned something that's very important for everybody to understand about when we observe things in the sky, is that when we are time travelers in astronomy, we look back in time, and it takes light that long, over 50 million years, to travel from this source, the galaxy here, M61, to planet Earth. Now think about this. What was going on about 50 million years ago? Well, we were in an era called the Eocene. At this time, if you're here in Florida, we would have been underwater. Now, me and Mr. Justin, we call ourselves Mr. Justin, Mr. Derek, because we do a lot of school groups all the time. So you might hear us accidentally say it because we do so many field trips. And if you're watching and you are interested in having us come and give a virtual program for your school group, let us know, and we'll be happy to do that for you. But Justin and I fossil hunt as well. We're fossil hunters, and we dig up ancient life forms. And one of the things that we have done is we have discovered fossils that date back to the time of this supernova. Marine animals, fish, sharks, things like that. Imagine a long time ago in the state of Florida being completely underwater with all these prehistoric marine animals going around, early primitive whales. Whales were starting to emerge. And it just gives you an idea of the fact, I mean, back then there were these big rhino creatures. There were miniature horses. I mean, there were just all kinds of interesting animals that lived during this time in the Eocene. And what's really interesting is that time, imagine those animals being there, these ancient marine life, all these other prehistoric creatures that roamed the earth at that time. That supernova just went off. That supernova just exploded. So when we look back in time, you know, we think we just seen the light from this supernova that just approached Earth. So think about this: if there was an ancient life, if there was intelligent life on in this galaxy, and they had some way of sending that signal straight to Earth, and we know that that's not truly possible because of the fact that the radio waves would just disperse and become just noise. If they had the ability to communicate straight to us, then we wouldn't get it for another 50 million years. And so it's just amazing that when we look at these objects in the sky like this, that in reality, we're going back in time. And, you know, but one really interesting thing about M61 is that M61 is called a starburst galaxy. Frank, have you heard about that term before, what a starburst galaxy is?
Yeah. Another famous example is M82, the Cigar Galaxy. They're just galaxies that are really, really active with star formation, right?
Yeah, so as this galaxy, as you can see here, this galaxy is a spiral galaxy. And believe it or not, the spiral arms of galaxies are not formed by the distribution of stars. They're actually formed by wavelets as the center of this galaxy is rotating. And that creates the distribution of stars. And what happens is hydrogen gas gets redistributed around these galaxies, and it kind of creates popping modes. Since some of this gas gets compressed and forms new stars. And this is happening quite a lot in this galaxy. So you get these rapid forming stars. And these stars are very hot, very bright stars, and they have a very short lifespan. They only last for a few million years until eventually they go supernova. So M61 actually has a lot of supernovas. For example, the designation for this supernova is SN supernova. 2020 when it was discovered, and the first letter is J. That, if it was the very first supernova discovered in this galaxy, it would have been an A. So imagine the fact that you have 26 letters, and then you get past that. If you discover 26 supernovas, you're going to have to add an AA, or in this case, a ZA, and you keep going. And so as you can see here, we've had a lot of supernovas discovered in this galaxy alone. So pretty incredible that this galaxy is constantly perpetuating or creating supernovas all the time. Pretty cool.
One of the factoids I read was that once every 50 years, on average, a galaxy the size of the Milky Way has a supernova. So you multiply that over, the millennia. These things are popping all the time.
That's right, exactly. They're going off all the time. I mean, so supernovas are not a rare occurrence, but I think it's still incredible for us to be able to observe these things. And Frank, you're about to say something.
Yeah, I just wanted to reinforce that, this is an actual photo taken from here in Central Florida. So, like you were saying, we can see this stuff. This was taken not far from here at all, using that same telescope that we normally use when it has a clear night here.
And Frank, we might have a lot of new viewers tonight that aren't familiar with your rig and with what we do on Friday nights here. Can you kind of walk the average person through, how did you get an image like this? Because this isn't something you're just going to, grab a telescope off the shelf and see. So what's different about what you did to be able to pull this out?
Yeah, that is an important point to make. And by the way, is that coming up on the screen? I don't have the permissions to pin it, but okay, you can see it. Great.
Yeah, it
Just
does.
sure.
Yeah,
it looks
all right,
good.
cool. All right, cool. Yeah, but that's a good point. Like you can't expect to see something like this if you just pull out a telescope out of the garage and point it at the sky and look at it with your eyeball. For things like this, we need to do what we call long exposures. So this is actually a combination of 5 hours worth of exposures that were taken on this galaxy, over multiple nights. And that's how we bring out that detail. We just let the light, the photons from this distant galaxy hit the sensor of our camera for 5 hours. And that's how long it takes to get an image like this.
Okay. And a couple questions from the gallery. We had one for either you, Derek, or Frank. Do we know, there's no medium for sound in space, but do we know what kind of sound would come off of a supernova if we could hear one? It's a great question.
That's an interesting point. Yeah. Probably. No, I don't know. That's just, well, we can. That's actually an interesting point because when we're discovering gravitational waves, which is actually a new field of astronomy, as we become more sensitive to those measurements, we'll be able to actually detect these waves that are coming from these supernovas. But as far as sound, I don't really know too much about the, I'm sure that there are radio observations of supernovas that, especially in very far galaxies, we call them quasars, that I'm sure that there are observations of those. But as far as listening to like audio of a supernova, it's not what you would think if you're not going to hear is, it's just not going to work. Now, because the energy that's produced in these supernovas are, especially close by, are intense energy. We're talking in the X-ray and gamma rays, which are highly energized matter. So, you have to have a very far supernova, so far away for that, those gamma and X-rays to eventually their wavelengths will eventually soothe out, so that way they can be heard, if you will, through radio telescopes. But yeah, as far as actually like hearing something, no, that would not be. You wouldn't actually hear like a dynamite exploding or something like that.
All right.
And you definitely wouldn't want to be that close to it anyway.
You wouldn't want to be close. No.
You'd need some pretty powerful sunblock.
Right. Exactly. So,
Frank, we had a question about the brightness of the supernova. Do we know, or Frank or Derek, has it peaked, or are we still seeing it get brighter? Is it starting to dim? Where are we at based on what you've seen so far?
Last I read, it is expected to continue brightening in the coming weeks. So we don't think it's peaked yet. That data is That factoid's a few days old, but I think it's still true. I don't know, Derek, if you heard anything else about that.
Yeah, I've heard a similar thing. Essentially, this supernova is still brightening, and there's a lot of amateur astronomers that are actually making these observations. What they're doing is they're looking at this star and this object and referencing it to other stars. And if you were tuning into our last virtual star party, you remember Barbara Harris. She was talking about variable stars, a very similar methodology we use with supernovas. We look at the brightness of nearby stars, reference them to the star of supernova, and eventually we'll start to see a dimming effect. And when that happens, eventually the star will disappear altogether. So right now we're still waiting on that data.
Yeah, and the other one we're going to look at later is much further along in brightening, actually. So we can look at what this might look like in the future as well.
Yeah, so this particular supernova is called a Type 2 supernova. And Type 2 supernovas usually, what is a Type 2 supernova? Well, first things first, a Type 2 supernova usually happens when you have a star that just explodes and the outer shells of that star are intact. So it's usually a primary star. And what you find is you find a lot of hydrogen, So astronomers, what they do is they look at absorption lines in the light. And they find certain spectra of that material, and they find out, well, there could be hydrogen, there could be oxygen, so on. And we also, when we do observations, we notice when we look at supernovas, we see a lot of red, which suggests that it's hydrogen and other gases as well. Well, that's what makes a Type 2 supernova, mainly a Type 2 supernova, is we find a lot of hydrogen, which means that that was a primary star, a very large star that was fusing hydrogen. It was primarily made up of hydrogen, and eventually the core collapses, explodes, and all that hydrogen goes out. That's kind of what defines a Type 2 supernova. And what I like to do right now is I'm going to share you all a video here of in Space Engine of a Type 2 supernova. This is a famous one. This is called Kepler's Supernova. So we're going to go ahead and fly to Kepler's Supernova here. And as you can see here, Kepler's Supernova is this beautiful, as you can see, very deep red. And that suggests that, and especially Frank, you are a imager. So when you see red, what does that suggest to you?
That screams hydrogen to me.
Hydrogen, yeah. So you can see that this star was rich with hydrogen. And when that star exploded, all of that material that was once found in the star is now dispersed out into the universe here. So again, we have this really nice, beautiful three-dimensionality of a once ancient supernova. Now, Justin, you said you had some interesting facts about the Kepler supernova, right?
Well, it's one of the most recent that are pretty nearby. I mean, relatively. This one is in Ophiuchus, so it's just a gorgeous supernova that is relatively close. A lot of times we see supernova that are in other galaxies, but it's rare that we see one that is in the Milky Way. And so this is pretty neat to be able to see a supernova here that is relatively close, that is not some far off galaxy, right here within our island of stars. I think that makes a lot of the supernovas nearby even more special.
So this happened in the 1600s, right?
1604, I think.
1604. So, is there any? Have you read anything about what they would have seen? What would this have looked like to the observer?
This one, from what I could tell, was not necessarily as bright as some of the previous ones. Like Chaco Canyon, they said was pretty bright, and Supernova 185, which was in Centaurus, they said, based on the records that the humans have recorded, it lasted for 8 months in the sky. And I think typically we would see a supernova for 30, 60 days tops, but 8 months would just be absolutely fantastic. And if you think about something that was that far away and that bright for that long, when we talk about Spica, or we talk about Betelgeuse that are so much closer, when you talk about being able to read a book by the light of a supernova, or to be able to see it in the sky as as bright as the full moon during the day, just gives you an idea of the energy that is coming off of these objects. We're talking about some of the most incredible energy in the universe.
Exactly. It's one of the most amazing experiences that happens in our universe. And what I'm going to do now is I'm going to go ahead and share you all. We're going to go back to Stellarium. And what we're going to do is we're going to go ahead and take a look at where the location is for M61. So M61 is located kind of towards Virgo. So just where we were earlier with Spica. Remember, we were talking about Spica being eventually a supernova in and of itself. And what we want to do is we want to look kind of towards the shoulders of Virgo here. She almost looks like she's jumping into like a pit or something. That's how I see her. And if we take a look at M61, we can see that she's kind of over where her head would be. And there's a nice bright star here that is at the very far back of Leo called the Nebula. That literally means tail of lion. So if we were to zoom in here, eventually we would be able to see this galaxy. Now, Frank, you used a 190 millimeter magnetonian, so that's about 8 inches or so.
Yeah, a little less than 8 inches. Yeah.
Yeah, a little bit less, but close enough. So an 8-inch telescope could see at least the core of M61 in a fairly, you don't have to have the darkest skies in the world, but you definitely should be able to see that supernova though. And you should see it right next to that main star right here. There's a bright star right here, and it will be just above it. So you almost make a triangle between the core and the star, and then the one just above it has more of a bluish color to it. That right there is, and that is a supernova in M61. So again, take a look if you get a chance on your own time. If you have a telescope, look towards Virgo, and hopefully you'll get a chance to be able to see that. So not only do we have M61 in the sky, but we also have another supernova. And Frank, you have a view of that, right?
Yeah, I was taking my telescope out to calibrate it earlier this week and grabbed a 10-minute exposure of NGC 3643, which is a distant galaxy in the constellation Leo. And if you look for that smudge, I'm not sure if you can see my cursor or not, but it's
no,
the smudge.
Unfortunately, we can't see your cursor.
Yeah, so look for that smudgy thing toward right of the center there, like a little bit right of center.
There's a lot of smudgy things, Frank.
Yeah. Do we have like the little like virtual marker thing here? Maybe. Let's see.
Well, if you're sharing your screen, you should.
Wait. There we go.
Okay.
So now it's centered. Okay, so that tiny little smudge in the center there, that has a little dot above it. That dot is actually a supernova within that tiny, faint little galaxy.
Frank, you might have the ability to annotate this. If you're sharing your screen, there should be an annotation feature that might be able to allow you to draw the site that people can see. You should be able to
actually
see that
sharing, but
if you're looking at Zoom, you should have that ability.
this is actually not sharing my screen, so it doesn't quite work that way with Zoom. But it should be dead center. Y'all see it, right?
Dead center. All right.
Yes.
Yeah.
All right.
I just want to make sure our audience is seeing. We're a lot more homed in on these things than our audience may be. So I just wanted to make sure that we. Let me see. I wonder if
it's easy to miss.
I wonder if I can annotate.
I think you can as the host.
So let me see.
You've got all the power there, Derek.
You do.
But
You're hoarding it.
It's not showing me. I cannot annotate, unfortunately.
Yeah,
so,
there's something weird about our settings.
Yeah, no, it's not letting me annotate.
And Derek, while we're talking about type 2s, what is it about iron that makes these things pop?
So all the other elements can be compressed pretty easily in a star, but iron takes energy to compress, and just the sheer amount of energy that's required to do that is just impossible. And what happens is that the star just literally just compresses really, really hard to try to get that iron compressed, and just keeps compressing and compressing and compressing, and that it just gets smaller and smaller and smaller, and these things get more tightly, the electrons and the atoms get more tightly bound. And while this happens, that tug of war effect between a star is exploding, but gravity is kind of holding that explosion together. That tug of war balance ends, and then all that energy that was stored trying to compress those iron atoms, kaboom! The star just collapses and blows apart.
So it's this beautiful balance of equilibrium that's keeping these stars together, that main sequence, right?
Yes, exactly. And actually during our third grade programs, we actually have a really cool, we actually talk about what we call the HR diagram, which is a diagram that kind of shows the life cycles of stars. So our sun doesn't have enough mass to reach a supernova on its own. But if you had a star the size of our sun that dies, the core is left off, and it becomes basically a big ball of hot carbon called a white dwarf. Now, let's just say, hypothetically speaking, our little white dwarf was around another star. Let's say Jupiter, for fun, was another star. And this white dwarf is gravitationally bound around this other star. And what happens is that the material from that other star starts to kind of ooze or kind of pull towards that white dwarf. And it kind of gets this very hot material, hot energetic material around it. And eventually what happens is the mass becomes 1.4 times greater than the mass of solar masses. And we call it the Chandrasekhar limit. And what happens is that star, just like with the supernova that we saw, the type 2 supernova, what happens? It just has all this hot fuel, all this fuel necessary for a kaboom.
It's like a hydrogen overdose, huh?
Like a hydrogen overdose. And this is what this one's happening. This one here in Leo, this supernova that you're seeing is a type 1A supernova. And that's what we have. So our sun doesn't have enough mass to go supernova, but what if the sun had a binary or a partner star and it finally died? It could still technically go supernova if it has the right conditions. And this is what's happening here in this object in Leo.
Yeah, and what's really interesting is that supernova that you're seeing right above it, it's actually brighter than the whole galaxy, like substantially so, and that just blows my mind. And it's getting brighter. This was discovered in late April, and it's had a little bit more time to grow and become more bright over time.
And it's just crazy. This little smudge that you see right in the center there, and that bright star above it, that is in the same galaxy. That's just crazy to me. And what's the distance of this galaxy?
I think it's around 80 million light years, if I remember right.
80 million. So Justin,
95 million.
95 million. So dinosaurs were roaming the Earth when this happened.
One of the things you said about M61 being 50 million light years away, and if they had a way to communicate with the Milky Way galaxy and somehow get a message to Earth over the course of 50 million years, let's say we receive it and we can understand it and we decide to send a response. It's going to take 50 million years to send a response back to them to get. So just that really even more magnifies how much space is out there.
It's just incredible. It really, truly is. Just how big and vast space is. That's an underrated statement for sure. Anyway, so that's a type 1A supernova that we're seeing here. And so pretty cool stuff. Now, Justin, do we have any questions from the audience about anything we're looking at here?
Yes, so we've got a couple CFAS members joining us tonight, John and Eric and Mauricio and Len, so thank you for tuning in. We got Professor Laura tuning in. Mauricio asked an interesting question. When we have the differences in supernova, some that last 30 days, some that last 60 days, some that last 8 months, do we know what is causing this variance in how long we can view a supernova? Do we know the method behind that?
Well, it's about fuel. And the more explosive force you get, the brighter something will get. Distance has a factor as well. There are delays in time, obviously. But a lot of it has to do with just the distance, how bright, how explosive this is, how long the explosion goes. Think about this. Imagine you had a volcano that erupted, sometimes you have volcanic eruptions that happen very quickly, and then you have some volcanic eruptions that happen slower. And I think it has, it has to do with how much energy was stored in that as that core was beginning to collapse versus another one. So it really all depends on the size, the conditions of what was happening in the core, and the amount of energy released during that initial explosion. And sometimes you actually have stars that almost pulsate. You get a first explosion, and then it kind of has this aftershock that sends more material out. And sometimes that can happen as well.
And these type 1A supernovas that we were just looking at, they're like a standard candle though, right? Like you can pretty well predict what they're going to do in terms of brightness.
Yeah, so there's a little bit more stability with the type 1A supernovas. And that's actually one of the techniques that is used for measuring the distance of these galaxies. And later on, figuring out that these galaxies are expanding away from us, and that there's this mysterious dark energy that's also accelerating these galaxies away from us. And so really the discovery of these type 1A supernovas in these galaxies have helped us figure out kind of what's going on in the universe, what's going on out there in terms of the evolution of our cosmos.
Great question.
So, Mauricio, great question. And speaking of which, you and several others are members of the Central Florida Astronomical Society, and both Justin and Frank are sporting some Cephas shirts. I didn't get the memo. I should have worn mine. But hey, next week I'll wear mine in support. But do either of you guys want to talk about Cephas and what they do and all that?
Take it, Frank.
All right, I'll take it. Yeah, Cephas is the Central Florida Astronomical Society. So if you live anywhere near Central Florida, Orlando, we're actually sort of based around Sanford, where the Planetarium is. And under normal circumstances, we meet there for our monthly meetings. These days, we're doing it virtually like everything else, but we're still having fun. So yeah, if you want to meet some like-minded people, some fellow astronomy buffs and enthusiasts, and get out there and kind of share your passion with the community, it's a great organization to join. Just head to cfas.org. And you can sign up for membership there. It's cheap. It's good people. And once you're a member, you can even get a T-shirt of your own.
Excellent.
Yeah, that's how I met you guys, was going to a Cephas meeting, and my wife actually found it online. She's like, "Hey, you love all this stuff. You should probably go to check out one of these meetings." And there's some people that share a lot of the same interests. And you've got this collection of just fantastic individuals who are so passionate about this type of stuff and do everything from, a lot of times you think, oh, if I'm going to get into this club, I'm going to be the newbie and I'm not going to know anything and I'm not going to fit in. Wrong. We've got just everybody loves to just get together and they love to help each other. And let's say you've got a telescope, you got it as a gift, you bought one and you just started messing around with it, it wasn't working out. This is the perfect forum to be able to ask these questions, take your telescope in. They'll set it up for you, calibrate it, will help you be able to start your journey, because that's exactly what this is. I mean, one of the most satisfying things that I've found as being a member is our outreach, taking the telescope out to Altamont Springs or out to a park or out anywhere, setting this up. And all of a sudden you've got a line of people behind you and you're showing them Saturn for the first time. Some of these people might be a 10-year-old kid. Some of them might be an 85-year-old woman who has never seen Saturn through a telescope. Yeah, and it is so satisfying to be able to share this with other people, because it's just awesome stuff. So I think that's probably the biggest thing for me is you got a group of people who love this stuff, love to help, and it's just a great way to share that passion.
Yeah, and I got a chance to join Cephas when I was 13 years old, and nothing has changed since now. And I could tell you that Cephas has definitely inspired me to be who I am today and really foster that early knowledge in astronomy for me. So I think that it was very exciting to be part of that and to still be part of that. If you're interested in joining Cephas, we normally would meet at the Planetarium on the second Wednesdays of the month, but we are currently not doing that. But we are actually meeting here on Zoom. But again, if you're interested, Justin will leave you all a link to our website that you can join, and also to our Facebook, or to the Cephas Facebook page as well. So be sure to give them some love, like them. And if you're really into this stuff and you live in Central Florida, please consider joining us, and we have lots of different opportunities. Now, there are some interesting objects in the sky that you can observe that are supernova remnants. So some of the things I showed you, like, for example, the Kepler Supernova in the space engine was a supernova remnant. And Justin was talking about this event that occurred during the Chaco Canyon, which eventually led to the development of the Crab Nebula. And what we're going to do is we're going to take a little trip to the Crab Nebula and space engine. And while I do that, would either you, Frank, or Justin, talk a little about the Crab Nebula while I get this all set up?
Well, the Crab Nebula is Messier 1, so first in the list of Messier objects, and it is a supernova remnant. So this is basically the gas left over from that exploding star that the Native Americans in Chaco Canyon in New Mexico recorded on that ceiling that you were at.
And what you're seeing here, I mean, you're seeing the ghost of a larger star. I mean, these are the layers of different gases, carbon and oxygen, left over from this much larger dead star, leaving this just kind of white dwarf, hot burning star that has probably got the size of the Earth, but has the mass of about 300,000 times that of the Earth. So if you were to take a teaspoon of a white dwarf star, it would weigh thousands of tons. The density of what's left over after this death is just absolutely amazing.
Yeah, and is it actually that sort of burnt out husk of the star that's illuminating that gas around it? It's just such a pretty thing to look at.
Right, exactly. And of course, the bigger the stars you get, the more a chance for that core to continue to collapse and collapse and collapse. And what you get is you can get neutron stars, which are incredibly compact, dense groups of essentially the protons, electrons, basically mesh together, form those neutrons. And you have this big, or this small ball of dense neutrons. And this neutron star could be no bigger than even less than the planet Earth. Some of these neutron stars could be as dense as a city, but yet have more mass than anything you can imagine. And of course, beyond that, when a star explodes, a massive, massive star, like Betelgeuse or something bigger than that, you can have to the point where everything compresses so dense that it forms a singularity and it forms a black hole. And what we're going to do here is we're going to visit unfortunately, this is the only one I could find right now. This is technically the core of our Milky Way galaxy, which would have essentially been would have been an old cluster of stars. But what you're seeing here is you're seeing a black hole, a very supermassive black hole, but essentially black holes are very similar depending on their size. But these things are intense. The gravity from these black holes are so strong that light can't even escape it. But sometimes, just like a drain that's clogged up, this thing gets so much material pulled into its event horizon that sometimes it but spews out, basically deflects all this material at high velocities, creating these super powerful jets. And we zoom in down here, we can see the black hole. And what's really cool about this black hole is that as we get closer, we'll be able to see the fact that this black hole, it has so much gravity, it creates this thing called gravitational lensing. And gravitational lensing is caused by the fact that light is distorted surrounding the black hole. But, what are some really interesting things? What you guys have a fun black hole fact that you want to share with our audience that you've learned that just blows your mind about these gargantuan?
One of the ones that I get a lot from the kids is they think that these black holes are kind of like this goes around and just eats everything around it. And what's kind of surprising is, yeah, if you get really, really close to a black hole, it's probably going to pull you in. But if there was a black hole where our sun is right now, unless you were, maybe Mercury, you might be okay. They're not necessarily out there sucking in everything around them. They just have a lot of gravity as you're getting closer to that event horizon. So I think that's one of the big misconceptions about black holes is they're going around eating everything up, and that's really not true.
Although if you're close enough for that to happen, you get into my favorite word in the world of astronomy, which is spaghettification. Right?
Yes.
Definitely.
Where like the changes in gravity get so intense that even across the space of a 6-foot person, it would just gravitationally stretch you apart. So you don't want to get that close for sure.
That's kind of a cool view of this black hole.
That is beautiful.
That is very pretty.
While you guys are looking at that, we had a couple questions about, the supernovas that are found in the astronomical community. You've got obviously being found by professional astronomers, by amateur astronomers. How does the community find these? And then how's the communication network work in this type of area where you're finding and then communicating this information out to the community?
Do you want to start, Frank?
Well, I'm not really wired into that world myself, but this is kind of timely, right? Like they did just discover a black hole just 1,000 light years away from us in the Milky Way, and that was like a week ago, I think. And pulling up the article on that here, I mean, it looks like the way that it went down is basically an astronomer at the European Southern Observatory in Chile discovered this thing. Typically they will publish that and have their colleagues, double check it, make sure that it's really a thing, and when everybody agrees, then they'll start to leak it to the press. I mean, Derek, you've been more in the world of professional astronomy than I have. So am I summarizing that correctly?
Yeah, so everything needs to be peer reviewed. You don't want to have something leaked out without a lot of scrutiny. In science, we don't want to just have things out there and, we found something, but, any field of science, whether it be astronomy or geology, biology, whatever, you want to have this published in journals. You want to have people in that field review it, and you want to make sure that your findings are consistent with things that you have seen in the natural world. Or if you discovered something new, you want to make sure that other people are able to replicate those things that you have observed. And that's very important. So when we get news articles and things like that talking about certain things or whatever the case may be, we want to make sure that that stuff is properly been authorized by the astronomical professional world. And that can be hard, especially with a lot of stuff that goes on. And that's what we try to do. We try to give you all the information that we have researched to convey to you all, kind of the ambassadors of science knowledge, if you will. And so again, usually a lot of reputable sources have that information provided from them. And definitely some of those would be your astronomy magazine, Sky and Telescope magazine, some of the major astronomy, NASA. They, of course, have to release all their findings publicly. So again, a lot of that stuff will definitely be reputable. Definitely there are a lot of things, unfortunately, that come up recently that I've seen that are not true. But those are minor compared to the grand scale of things.
Nice. Well, we've got about 5 minutes left. Do you want to touch on hypernova, or is that a whole nother show?
Oh, well, that could be a whole other show. I don't know. What do you guys think? Should we talk about that? Or is there any other supernovas that you all like to look at in the sky that maybe we can make a quick observation? Unfortunately, we're getting rain right now here in Florida, or getting close to rain. So we're not able to do too much observing tonight, but we can. That's why we have Space Engine. We can virtually. Well, that's kind of meta. We can virtually.
Is the Dumbbell Nebula also a supernova remnant?
It is not. It's a planetary.
It's not. It's a planetary. That's right. Yeah. What's the difference there?
Okay. Yeah. So a planetary nebula, again, a size of our sun, a star a size of our sun will collapse too, but it doesn't have all that energy stored to blow up as a supernova. It's not compressing these huge atoms like iron and heavier elements and things like that. What will happen is that essentially the star will lose that competition between explosive force out and implosive force in, and the star will just start peeling off, start pulsating and pushing off some of this material off of its outer layers. And what will be left over is that white dwarf, and that white dwarf is essentially the remnants of that once hot, dense core that was fusing at that time. Usually it's between helium into carbon. Oh, okay. That was weird. Oh, I think my battery on my light went off. I think it has lost its light. Well,
I thought you were getting sucked into a black hole there.
It's time to. It's telling me it's time to end here. So, anyway, but yeah, that's essentially what's happening there with these planetary nebulas. And the white dwarf is bright enough that it's still releasing a ton of light and energy as it cools down. That's exciting the material found in that gas. That's what's creating that kind of glow that we see there. Let me see if I can look at the Veil Nebula. That's actually a very famous object. You can actually see the Veil later in the evening. So let me see if I can go ahead and share the Veil. So I'm going to go ahead and see if that's in there. All right, let's go ahead and, all right. Okay, so I think I'm going to have to look up the NGC number. Can one of you guys give me the NGC number for Veil? Because I think I might have to look it up that way in Space Engine.
I think there are
6960.
6960, yeah.
6960. All right. Oh, I typed in the wrong letter here.
That should take you to the Witch's Broom.
Okay, so it has right now. It does not have 6960. Interesting.
All right. 69...
Well, we broke Space Engine. Unless there's another one. If you have the other version, which
6992 or 6995 would also work.
It does not have that in there. It's skipping it. Oh, okay. Well, looks like we can't see it. Well, that's a shame. I'm trying to think of another good supernova to look. Oh, I know. We can look at this supernova. This is another beautiful supernova here. Let's go to this one. Okay, here we go. Oh, that's because the exposure's down. We were looking at that black hole earlier. Oh, this is another black hole. Okay. Oh, I accidentally hit the black hole. It's still really cool. Okay.
Oh yeah, look at that lensing.
This is pretty cool. Okay, we kind of we went into the wormhole. Let's go. Oh! All right, and we're having way too much fun now. All right, let's go back. So I think I accidentally. Here we go. All right. Either way, well now that's a nice thing. We discovered a new thing in. So
you're saying Matthew McConaughey can't really fly into a black hole?
No. Unfortunately, that spaghettification would get him there. But this is another beautiful supernova as well, and this is another view of the Kepler Supernova, just in a different kind of view here. So. So yeah, unfortunately, we're gonna have to, it seemed like those are the only ones they had in the software that we could find for supernovas. But one of the things I want to show you, actually, it looks like Frank has a picture of the Veil. So Frank, I'm gonna go ahead and
look at that.
There we go. See, we improvised there.
Yep, I dug this up. And this is just one piece of the Veil Nebula too. This is just like a little chunk of it that's kind of photogenic. It's actually a very large nebula in the sky. So this is just one small section. And yeah, I mean, like you said, this is all a supernova remnant, and this has apparently had a lot more time to sort of spread out and blow that gas out a little bit farther and make these, what ends up being really pretty patterns, as you see that those sheets of gas edge on here in this section that's called the Witch's Broom.
Yes, definitely. Again, it's up in October, so a perfect Halloween-themed thing. Maybe for the virtual star party, we'll include spooky things in the night sky. What do you think? Leave a comment in the chat. If you're on Facebook, if you like that idea, maybe around Halloween we'll do an episode on spooky objects of the sky. And just for those that are curious, if we were to open back up, the college was the word back up, we're allowed to do planetarium programs. We are in agreement. We're going to continue doing our virtual star parties, at least for the pretty much as much as we can. We're looking at probably hosting at least one a month, continuing going on. So we might not be doing them every week like we normally been doing, but we're going to continue to do them on. So we know that you all seem to really enjoy these, and we enjoy doing them, and it's a lot of fun. So we're definitely going to keep this going.
Yeah, and Derek, we got a show on Monday, kind of a different night of the week. What's going on Monday?
Oh, that's right. Thank you, Justin, for reminding me. We have it's not really a show, but it's an exciting event. We have 7 women from different fields of science, engineering, technology, arts, and mathematics. This is our Women in STEAM panel, and that's going to happen at 7 p.m. Eastern Standard or Eastern Daytime. That's going to be happening this upcoming Monday. So now, of course, for those that are watching on YouTube land, this has probably already happened for you, but we're going to have a link for that in our YouTube channel. So be sure to check that out too. We're going to have that video uploaded there as well. So for those that are on Facebook land, we're going to be doing that this Monday, upcoming Monday at 7 p.m. Eastern Daylight Time. And it's going to be a great chance for you to interact with some really talented folks. And we'd love to have you out there and enjoy that program. Now, I want to let you know about some of our other events coming up. Not only do we have that going on Monday, but on Thursday, we're going to be doing our virtual public show. And this week, we're going to be exploring the astronomy of Chile. We're going to be using some of our software here as well. And we have 2 guest planetarium speakers that are going to be joining us. We have 2. We have Dr. Shan Small and Tiffany Tiffany from the Ohio Youngstown, excuse me, it's been a long day, Youngstown University, joining us for that. So I hope that you all can join us for that as well.
That is going to be a great show because, I mean, we're all familiar with the Northern Hemisphere, but be able to get familiar with some new stars that we've never seen before, new constellations. How cool is that?
That's right, exactly. So we're going to be exploring the southern skies. So we're going to be looking at what you can see in Chile, this dark skies there. We're also going to be looking at the observatories that are doing the science, and we're going to be looking at some of the incredible discoveries that have been happening out there in Chile. So definitely check us out for that. And of course, we are going to be doing our virtual star parties, so we hope to see you all again. And again, thank you all for coming out and spending your time with us and exploring supernovas with us. And if you have any ideas for episodes for our virtual star party, let us know. You can always email us at planetarium@seminolestate.edu, or you can just leave a comment in the chat or in the Facebook Live comment section, and we will consider that for a future episode. So thank you again, and thank you for your support. And I hope all of you are staying safe out there, and we will see you next time. So thank you, everybody. Good night. We'll see you next time.